What's up, guys, and welcome back to Mr. Nolasco's Notes on Math 2. Today we are going to talk about factoring special cases. So this is just a little bit of review on things that we've talked about before. I'm going to go ahead and jump right into it. We're going to go all the way to example number 4. So that's 12x squared plus 4x. Notice that there's no third number here. So you can tell we have an A, which is 12, we have a B, which is 4, but we don't have a C. Most of you have these in your notes already, so this is for people who have maybe been gone or those who just need a little bit more of a refresher. So I went ahead and I took these notes on paper. I printed out this slide. So I'm going to show you what that looks like right here. So here I am in the bottom right now, and you can see Oscar in the top right. I did that. Let me know if you have any more suggestions, but I'm going to go ahead and get started. So we have sorry about that. We have the example here, 12x squared plus 4x. What we're going to start off with is label A, B, and C. So I want you to get into the habit of doing that every single time we have a quadratic expression. So A is 12, like I said earlier. B is 4, because those are the numbers that are right there, the coefficients. And then C, we don't really have one. You could put 0 or you could just leave it blank. So with that in mind, normally we would go straight into the diamond and we would go after that into making our area model and filling out all of those spaces. But what I want you to notice is that because there's no C, if we did use a diamond, A times C would be 0, and B would be 4. There's not really a whole lot that we can do with that. So I want you to take a closer look at the numbers that we have right here. I want you to be able to notice right away that both of them have an x. There's an x squared there, and there's an x right there. So I'm going to rewrite this just off to the side somewhere. Right here is good. Because I want to show you that you can look at these numbers and be able to factor some things out of them right away. For example, if I factor out an x and put whatever is left in here, 12x plus 4. All I did was I took 1x away, or basically I took 1x out of that x squared, and then I took that x out of the 4x. So when I do that, I have 12x, not x squared anymore, and I have just 4, no more x, because it's right there. So look again and notice that we can still take out a 4, because 4 goes into 4 one time, and it also goes into 12 3 times. So with that in mind, I'm going to rewrite this again, but I'm going to take the 4 out now. So by factoring out a 4, we're basically dividing by that 4. So when we divide 12 by 4, well, we have 3. And since I already took one x out from way up here, that x gets brought with us. And lastly, this 4 divided by 4, that's just going to be positive 1. And there's nothing else that we can factor out at this point, so this is actually going to be our answer. So I hope this helped you understand this type of special case a little bit more. I'm going to move on to another special case here. Okay, so now we're on slide 5 in your notes, which are posted on Google Classroom, by the way. So this special case starts 9x squared minus 100. This time, if I were to map out my, let's see over here, A, B, and C, we have A, that's 9. This time, we don't have a B, because there's no number here that has an x. There's an x squared, and then there's nothing, but there's no x. That x usually is what the number b would be next to. So we don't have one. That's 0. C is negative 100. Okay, let me fix this a little bit. My a looks like a 9. Okay, so we have a times c, and we can actually get a number this time. So 9 times negative 100, negative 900. B is 0, that goes on the bottom. So in this case, what we have to look for is a number that multiplies to negative 900 and adds to 0. So if we want two numbers to add to 0, that means they're going to have to cancel each other out. They're going to have to be opposites. So think of two numbers that are opposites of each other that cancel out. Those two numbers are going to be positive 30 and negative 30, because if you added those together, since they're opposites of each other, they cancel out to 0, so that works. And we all know that 3 times 3 is 9. You add the negative in one of those numbers, that makes the product negative. And then the two zeros in these two numbers just get added to the end of that 9 to make negative 900. So I'm going to take these two numbers, I'm going to put x's on them, and add them in our area model. Next, I'm going to take my ax squared, which is 9x squared, and my c, which is negative 100, and put those in the other two spaces in the box, in the area model here. So now we can take a look at what we can factor out of each row and each column. So between 30 and 100, I'm just looking at the numbers. Between 30 and 100, the biggest number that divides into both of those is just going to be 10. And there's not really an x that we can take out because both of them have to have x's and only one of them does. Same thing with the negative. There's only one here, not there. So I can't take out a negative. It defaults to being a positive number in this case. Looking at the bottom row, 9x squared and negative 30x. Again, one negative here, but this one's positive. So we know that the default is going to be positive. But they both have x's, so I can start by taking that out. And the biggest number that divides into 9 and 30 is going to be 3. So I'll pause there for a second because I want you to look at these two numbers and these two. So now we're switching to the columns, but pay attention, compare them to the rows that we just worked on. Notice the numbers are exactly the same. We have 30 and 9, 30 and 9. We have 130, 130. So the numbers are going to be the same. Maybe the signs would be a little different though. So between 9x squared and 30x, again, I know I can take out a 3x. Right here, two negatives. Oh snap, I can take out a negative. Right here is 10. So our answer ends up being, the factored form ends up being 3x plus 10 times 3x minus 10. And that's it. So we've completely factored this expression. This is called a perfect square. I'm sorry, this is called a difference of two squares. Now, this method won't necessarily always work for this particular special case, because when you have a difference of squares, sometimes you won't be able to factor out some things from the area model. At least it won't be so obvious. But whenever you notice that you're looking at a difference of squares, it's always going to take this form. So if we have, let me kind of create a break here, 9x squared minus 100. This is our a, that 9, just the 9, not the 9x squared, just the 9. This right here, the negative 100, is our c. So if you look at the factored form that we got, 3 is the square root of 9, and 10 is the square root of 100. And if I look at this one, the numbers are the same. So again, 3 is the square root of 9, 10 is the square root of 100. That's not a coincidence. This is always going to take the form of the square root of a, x, plus the square root of c, and then times the square root of a x minus the square root of c. I know it's a little bit hard to tell with the letters, when there's not any numbers there, but this is what it's always going to look like, no matter what numbers you have, as long as you're looking at a difference of squares. So let me just come up with another random example here. We'll call this number 6, why not? And I'll say this is 4x squared minus 25. And again, that key word in the name of this difference of squares, the key word is difference. So it has to be minus right there. If it's not minus, then this won't work. But I can take a huge shortcut by working this problem out, knowing what the end result is always going to look like. So I take the square root of a, 2, I put the x, plus square root of 25, which is 5. And then that's it. I'm looking at my other term now, the square root of a, which is 2x, minus the square root of c, which is 5. That's it. If I were to plug those numbers in to the area model, you don't have to do this, but I just want you to notice something. 2x plus 5, 2x minus 5. If I multiply these out, I should end up with exactly what we started with. 2x times 2x is 4x squared. 5 times 2x is 10x. 2x times negative 5 is negative 10x. Think about what that means for these two boxes once we combine those terms. And then 5 times negative 5 is negative 25. So our area as a sum ends up being 4x squared, 10x minus 10x. Man, those are going to cancel. And all we have left is that 4x squared minus 25. So yes, this will always work as long as you know what the end is going to look like. So that's it for these two special cases. There are a couple of them in your homework. Don't forget to like, comment, subscribe. Let me know any way that I can do better. And I'll see you guys in the next one. Peace. Stay Gucci.